In this video, we will cover basic programming of the Gamewell-FCI product line. The program used is called CAMWorks, and it'll program E3 panels, S3 panels, and 7100s. When equations are programmed, they use Boolean logic. Boolean logic is a form of algebra that uses logical operators to determine if the equation is either true or false. They can be referred to as gates, and those are equivalent to addition, subtraction, and division in standard mathematics. It's said that if a true statement means the equation is the on state, and a false, the equation is in the off state. These are the gates available for use programming in Boolean logic. We're only going to talk about 4 of them, because that's the 4 that CAMWorks uses. The NOT gate is pretty simple. It takes whatever the input is and flips it over. So if it's a false on the input, it's true on the output. The AND gate requires both inputs to be true in order for the output to be true. The OR gate, shown here, as long as one of these inputs is true, the output will be true. And the XOR, the inputs need to be opposite. So you see here, as long as one of them is true and the other is false, the output is true. We can have more than 2 inputs on a gate, although CAMWorks doesn't allow that. But as you can see, for the AND gate, you need to have all of the inputs true in order for the output to be true. For the OR gate, as long as one of the inputs is true, the output will be true. Here are a couple of examples of something you may need to program on a fire alarm system. We have an elevator recall here, so if the second floor detector activates the main, first floor activates the alt, machine room activates the hat and the alternate, because it's connected with an OR gate right here. In this example, this is for a smoke purge fan, and we're ORing together the corridor detectors on all the floors, or together connecting to this AND gate. This AND gate is connected with OR through a NOT gate, and these 2 detectors are in the stairwell, and what we want to do is make it so that the smoke purge fan will not run if smoke is detected in the stairwell. So the way this operates, any of these detectors will turn on the purge fan in the hallway, but if a smoke detector in the stairwell activates, you'll see that it shuts off the purge fan. Let's take a look at this stairway fan one more time here. What we added was, in the command center at the fire panel, a couple of ASM switches. One of them is a manual run switch to manually start the fan. The other one is a manual off switch to shut off the fan if it's running. This is for fire department use, typically in an emergency. And you'll notice that if we have a stairwell detector that's in alarm, it shuts off the purge fan. This manual run will force the fan back on. And this is done, again, using NOT by inverting the state of this point and then running through an and these are ORed together. We'll take another look at our elevator. What we've done is we've added a bypass switch here in the fire panel to prevent elevator recall from happening when you press the switch. So if a recall event occurs, if you hit your bypass switch, it turns it off. See how that works? Because the switch is normally off, this NOT gate inverts that 0 to a 1, and it's fed to one side of each of these AND gates. So you always have a 1 here, here, and here, and you add a 1 here, so 2 1s gives you a 1 on the output and turns on the elevator recall. CAMWorks uses CAM statements, which mean conditional action message. And again, it's using Boolean logic and evaluates whether the equation is true or false. So the statements we're allowed to use is and all inputs must be true for that. And on your keyboard, you can use the ampersand symbol shown there as a shortcut instead of typing the word and. Or one of the inputs must be true, and there's the shortcut for an or statement when programming. On XOR, the inputs must be opposite, and there's the XOR shortcut. And the not just reverses the value of the input, and there's the shortcut shown there. CAM statements are programmed right here, and they can be programmed as output groups. Before we get too far into this, you're going to reference group numbers in the program, but really what you're referencing is a system status map or a bit. So group 125, it has the control bit is 300. The system status map will show you these. So under common mode status, shows that this is the silence bit. Condition flags, 440 is the general alarm bit. These are the SSM bits for the switches for your ASM16. So when you press switch 1, it's bit 448 that gets turned on. You'll see the input groups you assign to input devices. Those happen to line up. Group 1 is SSM bit 1. But the trouble for that bit, if you needed a light or some indicator, would be 101. The output groups you can reference. So if you turn on that first output group, number 125, its control bit is 300. If a trouble occurs on that group, it'll activate SSM bit 200. So we just wanted to cover that. Knowing that, if you wanted to write an equation here that says if the system's in alarm and you haven't pressed the silence, it would be node 0, group 440, and not node 0, group 400, which is a silence bit. Notice when you hit enter, it's going to put those shortcuts in. And you're always going to have to reference a node. Since this is a standalone system with only one node, then you'll always reference node 0. Let's look at the different types of CAM statements that are in CAMWorks. The top of the list is output groups, and these are typically used for controlling output modules or notification circuits. You can use them to turn on speaker circuits or whatever you need to do for your system. The CAM statements for the ASM is for the buttons that you add onto the panel, the ASM16, and you can program these lights to light up based on what you need. In this case, this would be an alarm on group 10, assigned to some input devices. Group 110 is the trouble bit for that. And then the green light, as long as you're not in alarm or trouble, then the green light will be lit. Scratchpads can be used as an intermediate equation and referenced in different output groups. So this is useful if you have some variables that might change across multiple output groups. You can make the change here, and you see here if we had multiple output groups referencing group 416 down through here, we can change it all just by changing this part. Moving along to special functions, we're going to skip over the schedule, the counters, and the sequence. They're typically not used. Timers, though, are used frequently for like an elevator recall shunt trip delay, and it's pretty easy to use. Just put in the time that you want, and then assign it to the output group that you want it to control. There, now output group 130, SSM bit 305, has a 90-second delay. The next set of CAM statements is the group disable. There's multiple tabs along the top. Input group will disable input devices that are assigned to this group here, group 1, and that's an ASM switch that would disable that. Output groups will inhibit the operation and disable an equation. So here an elevator module is assigned to group 180 and we've assigned a switch to disable that. You can disable your onboard NACs on the motherboard and your signaling line circuits. And in order for that to work, you need to put your ASM switch numbers in here with an OR statement so that it will work. Last thing we'll look at here is the easy test mode. If you have multi-criteria detectors, assigning an ASM switch and activating this will allow it to disable the time delay for the testing. One thing to note here, this SSM bit here, this is what can be used to light the yellow light on the ASM switch. So you need to remember to do that. When your NACs are bypassed, you'll need these numbers here to light that ASM switch. For your SLCs, use those numbers. The output groups, there's the number you would use to disable or to light your ASM light. The disable type tag is used to disable groups of devices that are assigned a number in the fourth column. If you look down below here, we have some detectors that have 600 in them, and they're in the elevator, machine room, and hoistway. So you can use an ASM button to disable all of those devices. If you had an auditorium that typically does plays and they want to be able to disable the smoke detectors while they're using their smoke machines, you can assign a button to do that. We're going to skip over the CAM for sensor output and reset inhibit because we've never had a need to use those. The CAM for the enunciators is if you have a touchscreen enunciator on your system. The screen will be blank unless you actually have some touchscreen enunciators. You can enable them, and then you can program these switches to do different bypass features, and you program the LEDs for those in this screen here. So when you bypass a group, you can put that disable bit to light up the green and red together, and the blink to indicate that that button has been pressed. The sounder-based coded patterns establish how the sounder bases will react. We typically put our sounder bases and utilize the 500 series output groups on them. What the help file says about the coded patterns is that if both columns are false, the base will sound a temporal 3. If you want a temporal 4, you need the second column to be true. So what you would do is put in your SSM bit for the input group that you assigned for the CO portion of that multi-criteria device. The advanced CAM allows you to do a lot of things that are difficult to do inside of the regular group programming. And what you can do is you can program in or select a set of input groups or them together to turn on an output. This normally is only used for advanced functions though. Now let's apply Boolean logic to a real-world scenario. Here we have a building and there's an exit stairwell, and at the top of that stairwell is a fan for pressurization of that stairwell. It'll pump fresh air into the stairwell to maintain clear air to help occupants evacuate. So we have a control module at the top of the stair. First thing we'll do is assign it a group. I assign it group 151. And then, what do the job specifications require? Should that fan operate on any alarm in the building, any smoke detector, any heat detector, pull station, or, and this is rather common, only activate on automatic smoke detectors on each floor, in which case now all of those detectors, you'll have to assign them a unique input group that's not used for anything else, and in the specifications it may require that that fan not run if smoke's detected in the stairwell. Additionally, there's going to be a control needed at the fire panel for that fan to manually start it or stop it as needed. Moving on to program, we have our switch module here, and we're going to define this switch to be the manual run, this switch to be the manual stop. And then we'll define how we want the lights to work next to each switch. So red steady next to the run will be the fan is running. Yellow steady will mean there's an alarm, but it's not running. And steady green is the switch normal. This one will be the switch is pressed. On the stop side, we'll make that LED blink, the red one, if the fan's not running, but it is an alarm. We'll make it blink if its run has been inhibited by the switch being pressed. So we'll start with our equation that we're going to use for group 151 to control that module. So we know that it needs to activate on a smoke alarm on one of the floors and not a stairwell detector or the manual stop. Now there's a little error here that we need to correct, because the way this will actually operate is it will activate the fan unless there's a smoke detector and a stairwell and alarm, but this or statement here says, or this button will turn it on. So we need to enclose that in parentheses so it does not applies to both of these inside the parentheses. And finally, enclose it in the parentheses, and then or the manual run button will override anything that happens on this side. Replacing the words with the SSM bits in CAMWorks, 51 is our floor alarm and not the stairway alarm or the manual stop. This parentheses close off, and then or the manual run. You can put the manual run in the beginning of the equation. It doesn't matter. It's just good to be consistent. You either do the automatic portion and then your manual, or typically do the manual and then the automatic. And then lastly, for the LED blinks, you need to look up the SSM bits. And what we've done is put them in here into our sheet so that we can put them into the program. Coming over into our program, we've already programmed our devices on loop 2, and notice that all of the corridor detectors here are assigned to group 51. The stairwell detectors are assigned to group 52. The manual stations, we don't want them to activate the pressurization per the job specifications. And the output device controlling the fan is here, and we've assigned it to group 151. Next, we'll go to our output groups, and you'll see that output group 151 we've already programmed as a Stair fan. This reads out, if you know what these groups are, is a smoke detector on a floor and not a smoke detector in the stairwell or the manual off button. The fan will run, or the manual fan run. This bit here will be needed when we program the ASM LEDs, and that is the SSM bit number for group 151, which is also shown on the system status map. The last thing we'll do is program our switch module. We had our ASM for our main elevator bypasses, but we needed to add a second one because smoke purge and fan pressurization typically needs to be in a separate module, separate switch module in a separate cabinet near the fire panel. So we've got the first switch designated as the manual fan run, and the ninth switch, because we wanted the two horizontally, remember there's 2 rows of 8, that'll be the manual fan stop. Then to program the lights for that, we're going to look at just switch 2. So the first switch, the one that'll be up on the upper left, there's our fan running group. There's our alarm, and the fan is not running, and steady green is the switch is not pressed. If I go down to switch 9, the only steady light I've got is the switch is not pressed. Looking at the LEDs blink, this tab here on switch 2, The only thing on the first switch, which is the fan manual run, is that we press the switch. I want to blink the green to tell the user they press the switch. And then we'll come down here. The red blink, we're in alarm, but the fan is not running. And the yellow and the green will blink whenever the switch is pressed. We hope that you found this video to be helpful and informative. Please like and subscribe for more content.